Hi, I'm Adisagamanpilla, founder and CEO of Feynman. So Feynman is a quantum computing copilot to help you create and run quantum algorithms on quantum simulators and quantum hardware. So welcome to the first episode of Running Quantum in a Minute. So in this whole series, what I'll be doing is I'll take popular questions from websites like Stack Overflow, Stack Exchange, Reddit, and try to take those questions to our quantum computing copilot and then run and see the solutions in a matter of minutes. Because usually running a quantum algorithm or creating one is months and months of work. So here you can see we can do them in a matter of minutes. So here's the platform. You can also visit feynmanhq.com and sign up and try it yourself. So let's get started with today's episode. So what I'm going to do is I have come to Stack Exchange and search for Qiskit grower algorithms. So Qiskit, you know, it's IBM's quantum computing framework, and grower is a quantum search algorithm. So this will bring immense exponential value when it comes to unstructured search. So I'm going to look for a question that is yet to be answered, and then let's take it and then run it on our copilot and see how the results are going to be. Okay, here we are. So this question, it says Qiskit implementation of grower's algorithm to search a list. So this was asked 3 years ago, and let's say, okay, there is someone who has given an answer, and here we have, you can see a few more the answers. So what we're going to do is we are going to take this question, run it on a quantum simulate and see the results. So let's first understand this question. So suppose I have a list of numbers from 0 to 32. That is an array like this. Okay, I want to find a number n in this list such that it satisfies a certain property. Say it's a prime number. How do I translate this to an oracle that can be used in the grower's algorithm in Qiskit? So here this person has tried to do it in a certain exercise. So yeah, okay, and yeah, let's see how our Feynman Copilot would do this. So I'm going to take a copy of this. I'm going to copy this, go to our Copilot platform, paste it, and I'm also going to say plot the results. So we can also see a visualization of the plots. So I'm going to click enter, and here we go. So you can just sit back and relax and let the Feynman Copilot do the rest. So now what you can see while the results are being generated, let me explain what's happening over here. So I have entered the prompt, and the quantum copilot is now thinking and creating the model for it. So and then it will generate the code. So you will see it's creating the Qiskit Python code that can be run on a simulator and an actual quantum computer. So first the code generation takes place. After the code generation is completed, you will see it will go and try to simulate or run the code. There can be issues, error in the code, requirement is not properly met. So there can be errors that could happening. Here you go. So here the code was generated. You can see the code has been generated, and then the simulation is running. If there are any errors, it will start again to try fixing it. So this will iterate until the right results and the right code is being generated, and then finally you can see the results. So let's hang on for a few minutes until the results are generated. Fantastic, we just got the results. So here we can see that after one error attempt, it has redone the calculations and given the proper results. So you can see the simulator status is a success, and we can see the results and the plots that has been generated for his use case. So let's see, the person had a question about applying growers or quantum search to an array, and he needed to pick this or do a search to a given criteria, and he has asked for some questions. So first the AI has given the briefing how to encode his solution to the algorithm. That is one thing, and the other side you can see the code and the results are here, and the results are in the language of what he understands, or in the language he is looking for, not just the cubic representations. So you can see the measurement results and success rates, and then finally the plots as well, to understand the exact requirement he has been looking for. So now this is how you could also try and use Feynman Quantum Computing Copilot to experiment. So with that, I invite all of you to come on board with Feynman Quantum Copilot and start running your quantum algorithms in minutes.